So welcome everyone. I'm Yaron Zakayor, VP Product at DeepChecks, and Jess is Jess. Can you introduce yourself for a second?
Yes. First, I want to check we're recording, right?
Yeah.
Okay, wonderful. Great. Yes, I'm Jessica Kerr. I am the engineering manager of developer relations at Honeycomb.io. You can find me online as Jessatron, jessatron.com, pretty much Jessatron everywhere. You can find your own online by Googling his name. It
Yeah, I'm
works.
too lazy to do these sophisticated things that Jess does. And we're going to talk today about LLM observability and how it's supported by LLM evaluation. So, Jess, you'll take us from here.
Right. So Honeycomb is an observability tool or platform, whatever you want to call it. And I care deeply about observability because I care about us building systems that work in their environments and work well for us. Definitions. Okay, what is observability? It is about knowing what's going on in your system because it tells us. Not because we're like amazing detectives and can pick up the little crumbs of database modifications and update dates, but because our software makes it easy for us to know what we're doing. How this happens is, I was going to tell you, observability as a word, it comes out of rocket science and control theory, because when you have a rocket, and you're building a missile, say, and you want to know how fast it's going, you don't like get up there in the sky in a plane with a radar gun. You get your rocket to tell you how fast it's going and where it is and what it's thinking about doing next and what data it based that decision on. That comes from telemetry. So telemetry is data emitted by a rocket or a software just to tell us, the operators, what's happening inside it. No other purpose. This is not customer data. It's not production data. It's just for us, designed to give us that observability, that insight into what's happening. And telemetry data comes from code, like everything. That code is called instrumentation. So instrumentation is lines of code or libraries that contain lines of code that exists just to give us this information, to make the software explain itself. Now, you already have instrumentation. If you ever write a log statement, that is technically instrumentation. It's for us to know what's going on. Now, a string log is not the best at telling us what's going on. I mean, it totally works really well locally on my machine when I'm running exactly one thing. It does not scale to production, so we can do better. The easiest way to do better these days is to use OpenTelemetry. OpenTelemetry is it's open source software and specs and conventions, and it's a lot of open source software. This open source project is governed by the CNCF, the Cloud Native Compute Foundation. It is the second biggest project in the CNCF. The first one is Kubernetes. So this is like a major, serious industrial strength open source suite of software projects, really. And it is designed to be vendor neutral and also give us automatic instrumentation that we can very quickly add to our code, and that emits telemetry that meets a certain standard. So OpenTelemetry is more than just instrumentation. It also includes specifications for the telemetry data itself. And that's really important because this data, older style observability data, could be logs in any friggin' format whatsoever. It could be metrics in like Prometheus or StatSteve format. It can be a bunch of different things. And it can be, and often it's vendor specific formats. But when you use OpenTelemetry, you're not tied to a particular observability tool, which is important because this slide points out that, like, okay, you start with instrumentation in your code and that emits telemetry and that lets you see what's happening. Well, not really. That data does not go directly into your head. Instead, it goes in, there's like a barrier between the software and us. It's not that easy. It goes into a database, and that database is searchable. And those searches make graphs and text and various other views on a screen. And that is what gives us the clues about what's going on in our system. So that database and search backend and UI, that is called a telemetry front end. And OpenTelemetry does not provide that. OpenTelemetry puts the data in a standard format so that many vendors can provide the telemetry front end. So Honeycomb accepts OTLP, but so does Datadog, so does New Relic, so does Sentry, sort of, and Splunk. So and open source projects like Jaeger and Zipkin. So you have flexibility in that space when you use OpenTelemetry. Highly recommend. Okay. Once your data is in that telemetry front end, you're going to be able to get clues. Oh, but there's one more sneaky piece that also comes in OpenTelemetry, and that is propagation. I give you this definition largely because I was like, I don't understand how this works, and therefore I am suspicious of it. Propagation explains how some of this observability works, how we link services together and get more than disconnected log statements. So propagation is there's not just one rocket, there's a lot of rockets. There's a lot of components in our software system. And whenever we pass like an HTTP call in between them, the OpenTelemetry libraries will sneak in there and add some data to a header so that we're able to link up the telemetry between the two components. And that's how we produce a map like this one this is kind of like an architecture diagram, but backwards. We get your software to draw this diagram so you know it's reality instead of trying to make the software match an architecture diagram. And this is really useful in general. Any distributed system can benefit from this, but here's the thing. When you add LLMs or any sort of AI that is non-deterministic, this kind of observability becomes even more essential. So when you have non-deterministic bits in your software, and that includes users, really, so really any software, you need to know what's going on in production. It is not enough to test the software, deploy it, test it a little bit more in a smoke test, and then reason that that means it's going to work all the time. That's not reality. Reality will surprise you. So you need great observability into production, and that means you need observability that works at scale, and you need it to be searchable dynamically. So at Honeycomb, okay, so our CTO, Charity Majors, brought the word observability into software in like 2016, and at the time she was like, observability is something different. It's like wide events and dynamic queries. But no, we have since apologized and said that no, everything you have is observability. Your logs are observability. Your metrics are observability. But also, there's a level of observability that not everybody has yet. So that's Observability 2.0, and it's what we need for any application with non-deterministic components like LLMs. So the difference is that in Observability 1.0, your standard logs and metrics, the people most familiar with the system are the ones that are great at debugging it, at figuring out what's going on. In Observability 2.0, where you're generating the graphs on the fly and you can graph anything and you can look at a trace that tells a story, we'll look at a trace later. The people who can find out what's wrong and learn new things about the system are the ones who are the most curious. Because observability should let you explore your system and ask new questions as quickly as you can think of them. All right, so I want you to be able to explore this observability, and then DeepChecks adds a whole nother level because we can explore, is it good? More on that later. But now I have a demo up and I need your help because we need to generate some data to look at in this webinar. So please go to quiz.honeydemo.io and you're going to see the ObservaQuiz. Let me show you the ObservaQuiz. And the ObservaQuiz is designed, here it is, quiz.honeydemo.io. Make this bigger. The ObservaQuiz is designed to let you experience observability in Honeycomb. So it will ask you to create a free Honeycomb account. enter your name for the leaderboard and begin. And then, oh, I meant to do this in a private window so I could show you what's going to happen. Okay, quiz dot, that one works too, honeydemo.io. All right, Jessitron again. All right, so you get to hear, do you already have a Honeycomb login? No, I expect that you don't. When you click this, it's going to open a new tab. So ObservaQuiz is in the background now and suggest that you sign up to Honeycomb. Now, Honeycomb has a free tier that's quite generous. It's like 20 million events a month you can send us and we'll store them for 60 days and let you query them as much as you want. No credit card, no obligation, free forever. Really useful for any small company. It's probably all you need, and or for tests, or for trying out OpenTelemetry, or for integrating with DeepChecks. So sign up with Google is the easiest. I'm not going to create an account because I have too many Honeycomb accounts already. Answer a few questions, and then it will take you to this screen. And this gives you an API key, and that's going to let ObservaQuiz send data, send telemetry to your Honeycomb team, so then you can check it out. So copy your API key, paste it into this box, push submit. I'm going to flip over to where I already had one. No, we do want Firefox. We want this one. Here we go. So I've already entered my API key over here. I'm going to click submit, and then the quiz begins. All right, so if you do this quiz, we'll be able to see your data, and we'll be able to see how DeepChecks evaluated the LLM's response to your data, because this is integrating with OpenAI. Okay, so I'm going to answer this question. How does your software tell you what is happening? Well, it sends telemetry to Honeycomb, and then I run queries and look at traces. How could it say that more clearly? Well, sometimes the traces are a little noisy. Too many spans. Okay, now when I hit submit, it's going to OpenAI. And the fun part is we're going to be able to see that. Okay, well, I got a 38 out of 68 this time. That's not super good. Traces can definitely get noisy. Have you considered implementing dynamic sampling? I actually do dynamic sampling, but maybe I could do it better. Oh, and it suggests that I create service level objectives. Okay, so this is doing what I asked it to. It's like talking about how I could move closer to observability 2.0. I didn't tell it that I already have service level objectives. Okay, I'm happy with that response. This is going to show up in DeepChecks. If you pick either sad or happy, we send that information to DeepChecks, and then we'll see what that looks like. All right, so pick something. Next question. There's a couple more questions in here, and after you do those questions, it'll like show you some data in Honeycomb. So you're welcome to play with that. But if you get through that first question, at least, then we're going to be able to see your data when we go look at it. The other thing you can do, the kind of the magic of ObservaQuiz, because it's sending telemetry to your Honeycomb instance, it can then link you to the trace in Honeycomb. Oh, man. Okay, well, it's not perfect. You're muted. If it's
Yes.
yeah.
People are asking how to get to the quiz. So
Oh, thank you.
if you can send the link here.
Oh, thank you. Yes. Quiz.honeydemo.io. Yes. Okay, good. And it's a little tricky because you do have to create a Honeycomb account, but hopefully that should be quick and it's free forever. And it will send you data. All right. And but before we go looking at all your data, Yaron is going to talk for a bit, so you have a little time. Trace. Okay, this one is not the best. I don't know. I think I have a bug.
Yeah,
It's a demo app. What do you do?
and guys, if you you see that I see that some of the people are stuck in some screens. So once
Oh, no.
I start speaking, Jess will be able to answer all of you and get this sorted out. So we're good. We have
Okay, yeah. On the screen with the API key. Takes the yeah. I don't know. Can people send screenshots? Rupali wants to know about application performance metrics. Oh, the fun part about Honeycomb is that any number on your span is a metric that you can aggregate. So we'll see that with some of the DeepChecks numbers later. But it does totally provide all the application performance metrics you need. Okay. ObservaQuiz. Oh, good. Jason saw some traces. It's a little tricky, by the way, going back and forth between the ObservaQuiz tab and it pops up Honeycomb in a new tab to try to point you to your API key. But the ObservaQuiz tab over here, if I click, I don't see this screen. It has some more instructions in it. If you want to click around in the API key, the please give me your API key page. It does have some more suggestions, like, yeah, like if you already have a Honeycomb account or an environment, there's another way to get an API key. And then you want to get back here and put the API key here. And it should be in a different tab. Okay, but we see a trace. Jason sees a trace. This trace, I made this up. This is not standard, but it does use OpenTelemetry libraries. I make some manual calls to them to create these. So I can see like how long the question was on the screen. And I can see that we made a couple fetches to the back end. Here's a post. Let me see what URL this was. Oh, wrong field. Ugh, kind of field is that? http.url. There we go. Okay, so this was a post to API questions, blah, 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 /answer. And that is the interesting one. Oh, and here's the opinion where I told it that it was good. I'm going to pop over. I chose not to link these traces together into one trace, but I made a span link over here. And this takes me to the back end. All right. Here is the back end of ObservaQuiz. And you can see what's going on when we post our answer to this question. We're going to ask the LLM for a response. Great. And that has a couple parts. There's the scoring. And the scoring does some chatting with the LLM. But you can see that it does two chat with LLMs in parallel at the same time. And meanwhile, and then it does score pointy words, which is, I wonder why we don't do that in parallel, but it doesn't matter. It's 9 microseconds. That's it. I've divided the scoring up into subjective elements that I need an LLM to interpret, and some no, those are the subjective ones, and an objective one, which is, does it include these words? And you can see, if I take the URL off and add score, you can see how many points I got from each component. Because a big part, I observe, there's a conference I was at last week, Emerging Tech East, and there were a couple talks about LLMs. Two things came out of that. One, everybody's asking about LLM evaluation, so you're in the right place for that. Two, separation of concerns is a big thing when we're using generative AI, because some components you want to use ChatGPT for, like a really heavy model, and other components you want to use like a lightweight classification model that you came up with, and other components you can implement deterministically. But in a trace like this, you can see what took so long. So we had a 4-second wait. It took 4 seconds for the backend to respond. It took us 2.5 seconds to score, but that wasn't the long pole of slowness. The long pole of slowness was these two things in series. So here's one. Okay, I'll tell you what this is doing. This is categorizing your response, and then this is constructing the text that it's going to say back to you. And then it's got this little piece, and this little piece, let me move this, hide this field. This little piece is me reporting the LLM interaction for evaluation. Because while I can tell you from here that it definitely didn't error, right? We did provide a response to the user. Was that response good? And this is really the burning question of LLM components inside our software applications. Are they working? Are they working worse or better? And for that, I need DeepChecks. So here I'm doing a post to DeepChecks. And let's see. I'm doing the post and we have, I want to see the ID. Oh, that's here. I'm sending this to DeepChecks right now. Where is my interaction ID? Here we go. And I have this interaction ID. And when I go to log in, I go to app.llm.deepchecks.com and it takes me to my application and I can go to data. I can click here. I can find the interaction ID. Ha! Okay, so now we see I've reported it to DeepChecks. I sent it the information. What was the input? What was the output? What was the prompt? Here's the full prompt. And DeepChecks declares this one good. Actually, it declares this one good because I told it was good because I hit the smiley face. But also, DeepChecks will come up with an estimated annotation of what it thinks. And then in addition to each individual interaction, I can also see an overall performance of my application. And as for what all of these things are, I'm going to let Yaron explain that.
Awesome. Thank you very much, Jess. And I'll just switch to a quick presentation and then continue the demo from exactly where Jess stopped it. So first of all, why do you need LLM evaluation? So I'm pretty sure that everyone on this call knows AI applications sometimes fail and sometimes fail miserably. So you don't want to be on the news of the Washington Post saying that TurboTax and HR Block now use AI for tax advice, and it's awful. Or you don't want to be in the news like Bing AI's chat was a couple of years ago, or you don't want to be in the situation that Goldman trading glitch could cost more than $100 million. Enough with that. So let's go to the interesting things. And so quick question that I'll post in a poll. In which stage of the application development lifecycle are? And that poll is going to go live soon. So let's start by looking at, you start with developing your application and you're experimenting. Which vector database I'm going to use, what embeddings model I'm going to use, which foundation model to use. So you do that, and you need LLM evaluation for that in order to objectively score which of the versions or which of your experiments is the best. Then you go and you do testing. So you are going to release a new prompt that's fixing a couple of bugs. How are you going to know that it doesn't introduce a regression? You need regression testing for that. Next thing you would do is do pre-production testing, and then you start, you are in the process of application observability. You need application observability because you're most likely going to use it to test it with thousands or more examples. How do you get quickly to the trace of the single interaction that failed? So you need something like just showed you. And then, of course, you move to production. I don't need to talk about why do you need production monitoring. So this integration between DeepChecks and Honeycomb actually provides you with the environment where you get an answer to all of the application development lifecycle. And give me a second and I'll run the poll. I'll open it for you guys. So here we go. Okay, I see that people are actually answering. I'll continue to speak and at some point show the results. So what type of problems one would encounter in an LLM application? Let's take a look at a RAG application example. So when you post a question, you can do nasty things like a jailbreak or other nasty things to break the LLM. So one should test for this. One should test for edge cases. You've tested your application with tons of cases. Now comes a new case and it breaks your application. Next thing you would do in a RAG application is go and retrieve information, most likely using a vector database. So you want your index to be of high quality. You want to measure the retrieval quality and relevance, and you want to make sure that there is no PII. What's an example of a PII? So let's say that you've retrieved the document, it has the IDs or the SSNs, the social your social number and social security number, and you definitely don't want to continue and pass that to the LLM. So you want to test for PII risk. Then you go to your LLM, and then other things can happen. You can get hallucinations. Probably I don't need to provide examples of hallucinations, but let's talk about specifically hallucinations in RAG. You get an answer based on the general knowledge of the LLM and not based on the information that you've provided it with the document that you've retrieved prior to that. Relevancy, completeness, toxicity, definitely you don't want to get toxicity. And then safety and bias are, of course, not something you would like to have in your application. So this all shows us LLM evaluation is hard, to put metrics and evaluate whether an interaction is good or bad with all of these aspects is hard, especially because LLM applications have a significant component that is not deterministic. That's the call to your LLM. So what are the key components that one needs in order to create valuable LLM evaluation? First thing you want to have is to build an evaluation set. What is that evaluation set? Think about classical machine learning. You had a test set. That's the equivalent. It's the set of interactions that you would use in order to test your application again and again. It's those that represent your production data. Usually, we recommend our customers to have at least 50 annotated samples in your evaluation set, but of course, the more the merrier. You want a good representation of your production set. Now that you have that in place, you can start and compare versions. You can do experiments and test all of them with your evaluation test before going to production. So both in testing and in production, you need to evaluate each and every sample. And then once you have each and every sample evaluated, you want to create a holistic score for your version or for your production day or week or whatever that is, and that's the overall performance evaluation. So what are the two components really that are needed? Build the data set for evaluation and compose an efficient evaluation, and we're going to see both of these later on. So what are the LLM evaluation methods that people do? And I'll stop the previous poll because there is a new one. And I'm sharing the results right now. So you can copy them. I'll do that in a second. And then So going back to what are the components that are needed? What are the methods that people do today? So some people would do manual evaluation. Our customers tell us that it's 3 to 5 minutes per sample. Sounds a lot, but actually, if you think about what do you need in order to evaluate a single sample, you'll see that it's reasonable amount of time. It says that you cannot really iterate fast because it will take you a day or a couple of days to go through an evaluation set. And it's going to cost you a lot of money. It's highly subjective and it requires domain expertise. So that's manual. The other thing that many companies do today is homegrown. So you do your own LLM evaluation. Some would do it via LLM as a judge. Some would do it via developing their own evaluation framework. That means that accuracy varies. It depends on the quality of the team that you put in place, and it's custom made. So it means that you're developing a lot, and if there's a new use case, you will have to redevelop a lot of the things that you've been doing. So the last thing that you would do is that you can do is to use a product like DeepChecks. We have competitors, so I'm going to talk about this category in general. What is the advantage of having a product? Of course, you pay for the service, but you don't need to upgrade it in order to address more use cases. Most of these solutions address multiple use cases. It's fast, so you don't need to wait until your evaluation team ends that development cycle. So you can start working on it as soon as possible. And something that we believe is unique to us is the capability of configuration, meaning customizing and controlling the scoring mechanism in a way that's going to be relevant to your use case, because there are aspects of your data and aspects of your application that are unique to you. And we in DeepChecks strongly believe that this segment of the market needs to be supported. I'm really interested to know what would be your answers to in which of the LLM evaluation methods you're using today. And by the way, if currently not evaluating, I see that some people answered that. That's an answer that we're hearing a lot of times. So don't feel ashamed if that's your answer. We spoke about DeepChecks. Now let's see what it's doing and how do we do that. So we said that building an evaluation system means that you need to first construct an evaluation set. So how do you construct it? There are two ways. You can do it manually. So you can have a sample that you believe represents your production. You can manually annotate it and then import it into our system. That's what most of our customers do. And then we also provide a way to do it via the assistance of an LLM. So our functionality will connect you with an LLM that's going to provide you with a set of a sample evaluation set. That's very helpful in order to get started, especially for people that are currently not evaluating. So most likely they don't have an evaluation set. Okay, now you're done. You have your initial data set, but of course it doesn't always represent your production data in 100%. You need to continuously update it, and in the following cases, you have bad examples. So meaning your application gave the wrong answer. There are edge cases that you haven't tried before. There are unknown answers. So the LLM doesn't know whether it's good or bad. You want to fix those and to integrate them into your testing database, so that testing data set, so that your evaluation set is going to represent what's really going on, and it will ensure that there's not going to be a regression introduced. And of course, as your application develops, people are going to ask new questions, people are going to come up with new cases, with new topics, and you want to address those as well. Once you're going through this recurring process, you want to continuously evaluate and use your evaluation system in order to actually test that your regression system works. And by doing that, you're also increasing, because what's going to happen is you're going to use your evaluation set, you're going to see issues, you're going to fix them, and you're going to increase your quality on an ongoing basis. So let's go to how do we evaluate. So the core of what we do is an automated scoring mechanism, and it's a combination of what we call properties. Those are basically metrics that represent specific aspects of your data, such as grounded in context, which helps you in removing hallucinations, such as toxicity, sentiment, a couple of the things that Jess was showing you. And those are computed by a combination of transformer models plus using LLM to compute specific things such as correctness, coverage, etc. The second method that we use is similarity. So if you have two versions and your answer to the same question is almost similar, you want to copy the annotation from your manually annotated system. The last thing, actually, and speaking about manual annotations, our recommendation is to have a single evaluation set that is manually annotated. We use those manual annotations in order to learn and improve our scoring based on the human score, because that's actually imitating humans is a great way to come up with better score. So a small pause, I'm ending the poll and sharing the results, and you can view them. And before I'm showing the demo, the evaluation criteria is really, the evaluation is composed out of quality and safety. So safety would be things like hallucination, bias, toxicity, and privacy. Quality are going to be things like task fulfillment. So did my LLM application gave an answer that answers the question? And the second thing would be logical correctness, which is this answer correct? And things like formality and readability are in the realm of quality. But really what you want is a combination of these two. You want a holistic approach that says, does this LLM application work well? And that's by combining safety and quality. And now let's switch to a quick demo to show how these things work. And I'm using a slightly different example than compared to what Jess was showing you in order to show variety. So this is a e-commerce summarization. It takes a product description page, think about a product brochure, and translate it into a short summary, and extracts product features and composes a JSON that you can actually present on the screen on a HTML page. So what do we see here? The most important thing, as you guessed already, is this score. It tells you that for this application with this specific version, the score is 58%. And you can see that, like we recommend our customers, this first version is going to be 100% user annotated. It enables us to take to the next version and have estimated annotations, which are automatically computed with in 97% of the time. So we scored almost all of these data samples. So going back to how do we score? So using things like, those are the properties like coverage, that's computed by an LLM. like reading time, reading ease, grounded in context, which is really important. It measures that the answer is based on the information that was retrieved from your documents. And it means that in this case, grounded in context is high. That means that hallucinations is low. And coherence, PII risk that we discussed is low here, which is good. And there are many, many more properties that you can see here. So properties, similarity, and let's take a look at a couple of specific examples. So the reason you see that the annotation here is low, is bad, the reason for that is that I came up with a specific custom LLM property, which means I wrote the prompt and very easily deployed it. That means using a UI. I'm a product manager, so no one wants me to code anything. So product features validation here was low. It's 2. The max is 5. It's really low. Therefore, it's estimated as bad. Coverage here is high. Product feature validation is high. That's why this is estimated as good. So that's one reason, based on property. I promised that there is similarity. So here is an example with similarity. There is a similar answer given in a previous answer. So we just copied the annotation, and you can actually go and compare that answer to the previous one. So you can actually see the reason. And so that's basically how we annotate. And there's a third option, which is not shown here because I don't have enough training examples. And that's learning from previous annotations. So I have that scoring done. Now what I can do are things like compare these versions. So in this case, we experimented with 3 different methods with the same prompt. One was using Claude as the LLM engine. The other was GPT 3.5 with default parameters and GPT 3.5 with temperature 0.75. Here it's clear what should go to production. GPT 3.5 v2, because the score here is the largest. And actually, this is, if you look into production, this is the version that went to production naturally. So evaluation here is pretty good. We went to production, and in production, we have 37%. So something went wrong when we went to production. We probably did not anticipate, something needs to be evaluated or investigated, excuse me. So simple, and this is the second thing you can do with this, is you can now go and figure out what's the root cause. And remember, this is only quote unquote the quality root cause. So I clicked on all of the bad examples, and now I can do things that are really cool. I can start taking specific properties, so specific metrics that I evaluated, and slice and dice them. So here I see that product feature validation was significantly lower. I'll do this, and I can get to some examples. And now I can see that all of these are bad, and I can drill in and see, okay, what went wrong here? So product feature validation is telling me that these are all null. And that means that there are 4 null values in the JSON, which means that we actually did not extract a lot of product information. Now, if I'm looking at the interaction output, okay, I'll try to read that. And I read that, the whole thing, and the data doesn't have enough product features in it. So the problem here is probably in extracting the data, extracting the initial input into the system. Okay, so that's the quality, and we need to fix that. So somebody will fix it, deploy it to production after going through the regression testing, and then take it from there. So summarizing it, this is the holistic picture with all samples. I showed how you can drill into a specific sample, similarly to what Jess showed from Honeycomb. And now we'll take it back to Jess. We'll show how it all combines into a holistic picture.
Okay, one more time with sound. First of all, let's look at the leaderboard from Honeycomb. Let's see. I was the only person to finish the quiz so far. If you finish ObservaQuiz, it will offer you a small prize. But we can also see various people's answers to the question, so we can see what's happening in production. I like this one. I like this one. I am just bombarded with dashboards and I have to figure out by myself what the problem is. Exactly. That is a very common problem. So we can look at what people said, which is fun, but what I really want to know is how these were evaluated in DeepChecks. And then the fun becomes, I can look for all of the spans that we created as a result of a callback. So DeepChecks does its evaluation stuff, and then it hits a webhook, and I made my webhook, it's just a little lambda, create a span, and we can look at the results. So here, as part of the application trace, I have the LLM evaluation results. Ooh, this one was fast. It only took like 26 seconds. And in this span, I can see so many properties. I can get, let's see, what do we have here? Well, here's a full report in JSON. Here's some words per sentence, email addresses count. I guess that's a PII thing. Lexical density, sentiment. Looks like the input sentiment was 0 for completely neutral. But then once we have, once we find something at all interesting, I want to know about like the sentiment in general for these things. So let's run another query and let's just get, I like a heat map because it shows the full distribution, but we could also look at like, what's the minimum sentiment? Go. All right, and let me change the granularity to make some dots bigger. There we go. All right, so we can see that this is the input sentiment. And for one of them, it was a little bit negative. Generally, they're clustered around 0. This person was really happy. Maybe that was me. But I can find out. I can click on any of these and be like, oh, well, who was really happy? And that takes me to the span inside that trace, and I can see who it was, and I can see what that input was. It raises its hand politely and says, excuse me. I got a really bad score on that answer. I think it gave me a 0, but apparently it had a positive sentiment. So maybe you care about the output sentiment. Let's look at the sentiment, output properties sentiment. We'll look at that one. And okay, sometimes it's a little negative. Usually it's positive. Then I can do,
Yeah, but
let's see.
nothing is really negative. Like minus,
Right.
yeah, it's fine.
Right. It's not bad. I could show you bubble up, which says, this is fun, which if I use the heat map, I can say, what's different about like the negative sentiment? And it'll tell me, well, the sentiment was negative. No kidding. The subjectivity was apparently really high in the ones with low sentiment. But also I could like go look at the actual one that it was.
Oh,
Right.
can you look into correlation between low correctness and
Correctness.
the final score?
Correctness is correctness. Is that grounded in context?
Um,
I don't see one named.
you know what? Let's do grounded in context
Yeah.
Yeah, that's awesome.
Oh, for the final score is someplace else in the trace. It's not on these particular events. And right now in this team, I can't ask it, hey, show me the the average of, or the heat map or whatever, or the min or whichever aggregation I want of the final score, given this by DeepChecks result. But next week I will be able to.
Awesome.
That is a feature that's coming out next week in general release in Honeycomb.
Awesome.
So yeah, so I'm not super worried about, like, I could do some extra work to add that data to the same span. Not going to do it. The last thing that I want to show is, while we can see overall results and stuff here, I might want to monitor for safety. And at Honeycomb, we conceive of monitoring a little bit differently. So if I want to look for toxic requests, I could create a trigger, and I mean, I could do this in Honeycomb. I could create a trigger that says, whoa, if there's a toxicity over 0.0001, what is our max toxicity? Toxicity of the output. Yeah, it's really low. Our max over the last few minutes is like this number. So I could put a trigger that says, if it gives me toxic output, page me. Don't page me for one. Page me if the toxicity overall has increased to an unacceptable level. And that's what a service level objective does. And here I've told it that 98% of our output responses should have a toxicity below this extremely small number. And in fact, I'm not quite making that. I've actually burned some of my error budget. And then if I scroll down, it tells me what's different about those. And oh, wait, let me change this to the last 30 days. What's different about the ones that are too toxic? And this here's my custom property, Olliness, short for observability-ness. It checks the relevance of the input. Did they actually talk about observability? And in the ones with a tiny bit too much toxicity, they weren't really talking about observability. So my responses might have been cranky. And I would show some more stuff, but we're at time. We have a few minutes for questions, so I want to stop there.
And just to summarize, so what we saw today is how the integration between observability and evaluation gives you the capability of really figuring out what is going in your application from testing to pre-production to production. And please, questions now. Okay, what do we have here?
Well, Icaro got the high score so far with 803 points at the ObservaQuiz. So hopefully they will send me their address and I'll send them some stickers.
Awesome. Let's see if there are any more questions.
Yay. Oh, here's one. How do you combine different signals from different metrics and methods of evaluation to compute that estimated score?
Awesome. So we use a rule-based engine to do that, and that rule-based engine is completely customizable. Right now, it's customizable via editing of a YAML file, but it's truly intuitive. Even I did it, which means it's simple. Cool. So I think we're a minute away. So really thank you. Let's see.
Yeah, if why use Honeycomb in addition to DeepChecks? Okay, yeah, thank you, Eric, for that question. Honeycomb does application observability. It shows you how all the different parts of your application fit together. DeepChecks evaluates individual LLM interactions. And so when you take the information about whether each LLM interaction was successful and you put it in the context of the application, then you can see, like, if I could do this by team or by username, for whom is the LLM not performing? And under what circumstances, for anything else in your application? Is it, I don't know, region? Is it, well, DeepChecks would tell you language. But Honeycomb lets you graph dynamically, and it lets you group by any field, including high cardinality fields like user ID. In DeepChecks, you can add a property that's like, you could add a property like of a category or environment or something like that. But you want it to be low cardinality. In Honeycomb, we don't care about cardinality. You can be like, show me the toxicity levels by user IP address. And it's a much finer grained level of slice and dicing.
Yep. Cool.
You can collect runtime metrics. There's the Honeycomb actually has a better way of doing that, but if you want to know about that, I'm Jessitron at honeycomb.io. You can get all the metrics multiple ways.
How are you creating ground truth for evaluation of test sets? So there are two methods of doing it. One is use a CSV, give it to a human evaluator, and they will evaluate it. The second method is use DeepChecks to do an estimated evaluation, which will give you a good first cut of a score, and then evaluate each and every one of our answers, validate it. You can override the estimated score and create the ground truth. Okay, let's see.
Venkat had a fun one. Yeah, say a user gave a thumbs down, you could send context to DeepChecks. I don't think it's easy to send the context to DeepChecks, but that context is in Honeycomb of like, DeepChecks would know what they typed in and what that response was for that single interaction. But in Honeycomb, you could look at what's that customer's overall experience of the product. What did they do before this? What did they do after this? What level of customer support does their account have? You could get a lot more context for that in Honeycomb, while DeepChecks gives you the super detailed, was this really a bad response, or are they just in a cranky kind of mood thing? Yes, different honey. Yes, because Venkat's point is really good. You can take the evaluation ID from DeepChecks if you're looking at stuff in DeepChecks and find that that interaction in Honeycomb and get the wider context.
So no, it's very rare that you get a different score.
Are you answering Humayun's question?
Human, yeah, sorry, human. Yeah. Human's question was, do you experience to rerun evaluation using LLM method on the same data set, but get different score every time? So the answer is it's very rare, because we don't rely on LLMs to do the evaluation. We just rely on LLM to do a very specific part of the evaluation. Most of our properties are transformer based, and there's more determinism in what we do. I wouldn't say it's 100% deterministic, but there's more determinism.
Oh, that's cool. Okay, so there's LLMs, and then there's other models that are more suited to the categorization.
Exactly.
Nice.
Yeah, we don't I mean, this is one of the things that we're really good at. We're not a solution that uses solely an LLM to evaluate an LLM, because then you're basically back to square one. You're using a non-deterministic system to evaluate a non-deterministic system.
Kind of like every human system. Thank you, everyone.
Thank you, everyone. So awesome. And my email is Yaron, Yaron, at deepchecks.com. Jess is Jessitron at honeycomb.io. Please communicate with us directly, and use Google to find me.
Thank you.
Thank you. Bye-bye.